Alright, good afternoon everyone. We're going to be talking about what is a limit. Seeing limit right now brings to a lot of people that the limit is something that's reached, that's the maximum of things, stuff like that. In mathematics, it looks at it. We look at limit in a different approach. It's pretty much something, almost precise to the basic definition of limit because it's really approaching something. So it's we're really talking about a function. So let's take a look at this function here. Let's say let f of x be a function, right? We know that the variable of the function is this. So what we're really saying is that a limit of a function is the value of the function, right? So the function itself will approach a value, we'll call it value L, as the variable gets nearer and nearer to a value. So this is the value x here. So that's the variable. So this is a value that we're trying to get to. So we take for consideration we're approaching this value from both sides. We are going to actually, as this value gets nearer and nearer to this, and this is what the value that x is trying to get to. And while this is happening, the function on the other end is really approaching the same value in this way, approaching that value held in this way, which is the limit of the function. So we can say, in other words, basic terms, regardless of whether you know about mathematics or not, as one thing approaches, for example, not just one thing, but as we look at the x is a variable, it could be anything, right? So when x is very close to a certain number, the question that you're really trying to ask is, what is y very close to? Which in terms, what is f of x very close to? So we're going to do an example to clarify any type of curiosity that you guys have, and that should take away a lot of things. So when you write function and limits, you write f of x, which is a function, and then we say the limit of f of x as x approaches a certain number. We don't know what that is, but that limit is equal to L. That's the limit, right? Equal to L. So what we're gonna do right now is an example to show exactly how this works. Limit of function. This is basic, guys. We are not going too hard because we don't want to. I don't really don't want to confuse anyone. So I'm going real simple here right now. So let's do this. The limit of a function. Let's write our f of x. Let f of x equal something basic. Let's say x squared, right? So limit of a function x squared as x approaches 2. Now this we don't know what is equal to. So remember, when we talked about it earlier, we talked about the fact that when x is very close to 2, right? What is y going to be close to? So we're going to approach 2. X is going to get nearer to 2 in both different directions. So that's to approach this, and then we need to know what is that function being equal to. So it's going to be the limit, and we approach as, so it's almost like a effect. As this go this way, this going this way, and as this goes that way, this is getting bigger to approach the value of the function as the variable x approach gets nearer and nearer to a certain value. So let's do this then. Let's look at it this way. Let's take a look from variables from the left side. So we're coming from the left, we're looking at 1.9. Right? This is going to be, let's say, x1. Let's say x2 equals to 1.99. x3 equals to 1.999. So these are some values that we're getting closer and closer and closer to 2 as we go along. So if we evaluate that value in the function, that means that we're plugging in the 1.9. Just in case you're not sure what it means to evaluate a function, we're plugging in the x1 as the new x into the function. Wherever we see your x, we're going to substitute the 1.9. And let's put my calculator in for 1.9. It's going to actually be, come on, 1.9 times 1.9. That's going to give me 3.61. 3.61, right? So now let's try the second value, because remember, we are going to be getting closer to this to 2. That's the goal. So we're really looking for 1.99 squared. That's equal to 1.99 times 1.99. don't have a scientific, but this will work for now. 3.9601. Now let's do one more approximation. That's the third value, which is 1.999. Right? So that 1.999 times 1.999 is going to be equal to 3.996. So as we can see, when we approach from the left, we're really going from a smaller value to a bigger value. So the left approach is coming from the bottom to that value in this example. So if we continue in this pattern and choose x4, what would x4 be? Think about it. Absolutely right, 1.9999. So as we continue to get closer to 2 from the left, we're getting closer to a value. Can anyone think of what that value is? Just look at it. Absolutely right, we're getting closer to 4. Now, in order for us to prove true, we're just assuming that's the answer. We need to make sure that it's the same from both sides. So let's go from the positive side now. So they'll call it a right hand limit. So there's two types of limit: left hand limit and the right hand limit. So let's do this to make sure that's the answer for that. So we're gonna have our new x1, which is equal to, let's say, 2.1, x2, and that's equal to 2.01. Of course, it's getting closer and closer. We have x x3 is equal to 2.001. So in reality, we're getting closer from the right. Alright, so now we're going to have f of x1. In this case, we're equaling to 2.1, so that's going to be your new input value. It's going to be 2.1 times 2.1 using the basic calculator. That's going to be 4.41. And then when we go to f of x2, we're equaling to 2.01 times 2.01. That's equal to phenomenal, 4.0401. Let's try one more. Let's put that x3 in and see what we're gonna get. So we have 2.001 times 2.001. That equals to 4.004001. Awesome. Woo! Look at that. Notice what's going on right here? Everyone should see that right now, what's going on right there. So we're also approaching the value of 4 when when x gets nearer and nearer to 2. So if we go back here, we can see that we're actually, this will be approaching from the right. So that means that the limit of this function will be approaching 4. So we're now safe to say that this value is equal to 4. So the value of the function when x approaches 2 will be equal to 4. Awesome definition if we think about it. Actually, I'm very happy to see that it came out so beautiful, because this is very hard to discuss a lot of times, but thinking about it in a simple way is something that makes it very easy for a lot of people. So what we're going to do next time is that we're going to do some more examples to make sure that everyone understands it before we continue into some real definitions. So the reality of it is, to make a very easy way to look at it, if we have the limit of a function such that, let's say, f of x is equal to x squared plus 2 as x approaches 5. This is the polynomial function, and pretty much it's continuous. We're going to talk later about continuous, but the idea really when working with this is that when we find the limit of a function is that a lot of people simply plug it in, and that's pretty much going to be where we just say we approach 5, so that's going to be the x value. Of course, that's going to become 25 plus 2, and that's equal to 27. So that looks a lot easier, but of course in math we want to prove things that as x approach the value of 5 from the left, and also as x approach the value of 5 from the right, this is what's going to happen here. This 27 here is going to be approached also from this side as approach from the left, from smaller to big, and then from big to smaller is going to be approach here from the right. So that will be the limit of this function. So that's the idea, really, what we're trying to get to. So next time in next video, we're getting a little bit deeper, a few more examples. When you do your examples, if you want to test it out, feel free to test it out to make sure that that one works. If you want to do it and do the examples by yourself by choosing values such as 4.9, 4.99, 4.999, 4.99999. That'll be values from the left. If you take values from the right, you're looking at 4. 5.1, 5.01, 5.001, and things of nature. So go ahead and give it a try. Bye, guys.